Sketch the curve for the pair of parametric equations. X is 5 sine t and y is 4 cos t. This isn't my first parametric equation video. If you saw the first one, this is how we set up the first one. We're going to set up this guy just like it. We're going to pick some t values. And when we pick our t values, x is going to equal 5 sine t, and then y is going to equal 4 cos t. What we do by doing this is whatever t value we choose, we get an x, we get a y, and that gives us some coordinates that we can draw out. So what I'm going to do is I'm going to pick basically every quarter of a pi from 0 to 2 pi. So I'll choose 0, I'll choose pi over 4, pi over 2, 3 pi over 4, pi, 5 pi over 4, 3 pi over 2, and 7 pi over 4. And I don't need to do 2 pi because 2 pi is just 0. All right, let's math. 5 sine 0 is the same as 5 times 0, which is 0. 5 sine pi over 4 is the same as 5. So sine pi over 4 is root 2 over 2. So 5 root 2 over 2. Okay, we'll deal with that when we have to deal with that. 5 sine 5 sine, I did it again. Pi over 2 is 5 times 1, which is 5. 5 sine 3 pi over 4 is going to be 5 root 2 over 2 again. 5 sine pi is 0, so u becomes 0. 5 sine 5 pi over 4, that's negative root 2 over 2, so negative 5 root 2 over 2. 5 sine 3 pi over 2 is negative 1, so negative 5. And then last but not least, 5 sine 7 pi over 4 is going to be negative 5 root 2 over 2. All right, fun. Now let's do the cosines. Let's do the y values. You get 4 cos 0, which is 4 times 1, which is 4. 4 cos pi over 4. Cosine pi over 4 is root 2 over 2. So 4 times root 2 over 2 is 2 root 2. Because things simplify out. 4 cos pi over 2. Cosine of pi over 2 is 0, so you're 0. 4 cos 3 pi over 4 is going to be negative root 2 over 2, so negative 2 root 2. 4 cos pi is going to be 4 times negative 1, so negative 4. 4 cos 5 pi over 4 is going to be 4 times negative root 2 over 2, so negative 2 root 2. 4 cos 3 pi over 2. 3 pi over 2 is 0, so 0. And then last but not least, 4 cos 7 pi over 4. Cosine of 7 pi over 4 is root 2 over 2, so 4 times root 2 over 2 is 2 root 2. All right. So I have a point of 0, 4. So when t begins, 0, 4, t is 0. This is where it gets interesting. Root 2 over 2 is like 0.7-ish, I believe. Yeah, root 2 over 2 is like 0.7. So 5 root 2 over 2 is like 3.5. So 2 root 2 is going to be like 3.5 again-ish. So I'm looking at, actually, yeah, you somewhere over here. Something like this, maybe. Something like that. And that's when t is pi over 4. 5, 0 is lovely. I can handle that. That's when t was pi over 2. And as you can see, we're working our way around. So let me try to recreate this the best that I can. That's when t is 3 pi over 4. Okay, when we're at pi, we're at 0, negative 4, so that's noish. Then we get negative 5 root 2 over 2, negative 2 root 2 over 2, 2 over 2, 2 over 2, 2, 2. You are going to look like this. And that's t equals 5 pi over 2. Then we have 3 pi over 2 is negative 5, 0. T is 3 pi over 2. And then you kind of complete out this ellipse-looking thing that lives like right around here. And that's when t is 7 pi over 4. So dot, 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 ellipse, 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 dot, 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 dot. And then we'll go this way, this way, this way, because that's when t is increasing. Look at that. So ellipses look like this is when you have like different numbers in front of sine and cosine. That's an ellipse. I wonder what would happen if you had the same number in front of sine and cosine. Circles, no spoiler alerts, it's just a circle. It's a circle. Oh, there you go, ellipse.